sensor. Where'd it go? There's also an oxygen sensor. Yeah.
Somewhere there's a.
Where is it? Oh, there it is. Yeah, right here. It should be actually on the outlet of the exhaust right here. Which it is.
What is it over there?
Because that's where the inlet to the turbo comes in, so probably the heat, you know, to make the turbo spin. In the meantime, the ECM is sending signals to the ICM. This is the ignition control module. This is the one that sends current to the drivers of this is a driver right here. Ignition coil pack. That's the one that steps up the voltage to make it so that it can jump the spark right here at the spark plug. And that's where I was telling you guys that a lot of times in the older systems, you will have, because I'm pretty sure there's still a lot of L10s out there in other states. Okay, they're out there. The same way as that PT pump that I disposed of a little bit is still out there in some. In Arizona, I saw a truck with a PT pump out there. Okay, but not in California. California, it's a no. And here's the decal that alternative fuels, powered engines or vehicles have to have some kind of ID for safety, for the first responders to a major accident, to a fire, to anything like that. It's got, when they see that, then now they know this is the protocol for this. Okay? First and foremost, the protocol for these CNG powered vehicles is to, if it's safe to do so, even a gas leak, you come over and you, where are you, baby? You shut off the main valve. Usually it's red, and you put it up crossways like a T, so that it cuts off all the gas from flowing. All right. First responder, if it's safe to get close to that vehicle, you could do that. If it's fully engulfed, let it ride. Bring the marshmallows out. Yeah, because there's really nothing you can do about it after that. What the fire department used to do, if it was a pressure release, and this is where the inlet for the gas, right? ECM is going to allow the primary gas control solenoid to either be activated a long time with a pulse width signal, or if you're just crawling at 5 miles an hour, it's not going to send a long on time, right? It's only going to allow it to open up so much. Once RPMs pick up, then the secondary comes in, helps it out, because when you have it floored, when you have peak demand, that's when you need peak delivery, so you can get the power out of it. This actuator, this whole assembly here, we call it the throttle plate. The throttle plate consists of a butterfly plate. I know you guys have seen this already once, but that's what this is right there, okay? Like this, sitting like that, and the magnetic field that gets sent to it allows it to open. It opens or closes, okay? And to go against that big spring in there, you need a good magnetic field. So what would you need to create a big magnetic field? Is good amperage flow, right? Or a way to kick up that magnetic field, which is amperes. And after that, it goes into the intake manifold, just like a car, into the intake manifold. Once in there, whatever intake valve opens up is going to allow that fuel to go in at the pressure coming in from the turbo, because the turbo is what forces it in, right? It'll go into the intake manifold, valves close, the ICM gets a command to send current to the coil pack for the plug that responsible for the one cylinder. Okay? And then ignition happens, torque happens, and you get power to the flywheel and the driveline and then the differential and the wheels. Okay? And like I told you guys, that the Metro buses were busting drivelines, how much torque they had. That was a heck of a lot of torque. They had to throttle down the ECM so that it would not allow so much fuel to go in there. I don't know exactly what the parameter they changed, but I would imagine it would be the pulse width modulation to the gas solenoids, because you need fuel to create power, right? You gotta get that energy out of the fuel and convert it to mechanical energy. Correct?